we're going to focus more on circular motion. Then in the afternoon, if we're going to have time, we're going to talk about work, energy, and power. Then tomorrow we are going to talk about linear momentum. Okay. So what is circular motion? When you hear the word circular motion, yesterday I mentioned to say, before we start this topic, I want you to understand linear motion. When we're talking about an object moving either in x direction or in y direction, we call that as linear motion. Okay? Now, linear motion, there is no difference with circular motion. As long as you understand linear motion, then there is okay. It's fine, you can understand circular motion within 10 minutes. Okay? So, whenever we are talking about linear motion, everything we are going to be adding linear. So if we are talking about displacement, now under linear motion we'd say linear displacement. An object is moving in a straight line. When we're talking about acceleration, this becomes linear acceleration under linear motion because we're talking about linear. Whenever we're talking about velocity, we call it linear velocity. Linear displacement is represented by d. Linear acceleration is represented by a. Linear velocity is represented by v. The same scenario, the same things that we are talking about here are the same things we're going to be talking about under circular motion. Now, in conclusion, circular motion is the motion that happens around the circle. Anything that moves around the circle, that is circular motion. Now, let me just give you a simple example. You are moving around the circle. There is a force that is acting toward the center, that is making you to move around the circle. That force, we call it centripetal force. So here is the circle. The force acting toward the center is centripetal force. Okay? When an object is moving around the circle or in a circular path or in a circular motion, all these guys are going to change from linear to angular, but these ones remain the same. Come on. So now when I go back to circular motion, linear displacement, we call it angular displacement. And it is represented by theta. This theta is the same angle, you know. That's angular displacement. So if the question is asking you to find the angular displacement or just the displacement, we are talking about circular motion, they want you to find the theta. They want you to find the angle. They want you to find the theta. Angle is going to be in rad or in revolution. Any question asking you to find the revolution, they want you to find the theta, which is the displacement. Another thing that I want you to understand is that we also have what we call angular velocity. Angular velocity is represented by omega, W. Then acceleration, we call it angular acceleration. And this is represented by alpha. These are the only things I want you to understand. So then if we are talking about initial angular velocity, it's going to be W initial, just like this. The final will be represented by that. Does it make sense? Someone to confirm if at all is making sense. If it's not, then we can end there. With this information, I can answer this question. Now look at this. Let me take you just. When we're talking about linear motion, we said V final So this is now what we call the relationship between linear motion and the circular motion. Circular motion is also known as rotational motion. So what happens here is that under linear motion, what we know is this. We know these formulas. V final is equal to the V initial plus acceleration times time. Then we also know that the d, which is the displacement, is equal to the V initial times time half at squared. Then we also know that V final squared is equal to the V initial squared plus 2AD. Now when we're talking about circular motion, remember what I said. I said when we're talking about circular motion, the V is now W. Again, that is going to be W initial plus acceleration is alpha, then times t. T doesn't change. This one becomes d is theta, v is this initial, time doesn't change, half alpha t doesn't change. Then this squared is equal to the initial squared plus 2 alpha theta. So these formulas, we use it for linear motion, these ones for circular motion. This is what we call the relationship between the linear motion and rotational motion, which is the circular motion. Now using this information, I believe the question 1 we can handle it. But before we solve question 1, let me first show you something. The full circle is 360 degrees. 360 degrees is same as 2 pi. This is now in rad. 2 pi rad is the same as 1 revolution. So when you start from this point, you move all the way to that point, you have moved 1 revolution. 1 revolution is 360 degrees. Because this is theta, we are talking about the linear displacement. In rad, that is 2 pi. So in a case where you want to change people from across, you can just mute your mics. So in a case where I want to change, I'm going to be using this, converting from revolution to rad. I'll be using this. I want you to understand that 1 revolution in 1 rev, there is 2 pi rad. So this is the conversion we're going to be using. Based on this information, let's go back and read this question. Then we see if at all we can answer something. If you are going to fail, then we have failed. So a wheel rotates with a constant angular acceleration of 3.5 rads per second squared. So I've not given you the SI units, right? Let me show you here. So the theta, it can either be in rad, that's the SI unit rad, but sometimes they will tell you that it is in revolution. Then the omega, it is in rad per second. Sometimes they are going to give you maybe in revolution per minute, but in most cases we need to change from revolution per minute to rad per second. Then alpha, which is the acceleration, is in rad per second squared, but sometimes they can give you to say it is revolution per maybe minute squared, but these are the SI units. Now we can go back to this question. A wheel rotates with a constant angular acceleration of 3.50 rads per second squared. But if the angular speed of the wheel is 2.00 rad per second at t is equal to 0, okay, through what angular displacement does the wheel rotate in 2 seconds? So let's look at this. The question is through what angular displacement? Now I want you to understand one thing here. Let's gather data. We need to have data here. Data is going to help you to choose which formula you are going to use among these 3. Okay, based on the data we're going to have, is going to help us which formula we're going to use. So let's gather data here. What information do we have? Angular acceleration, we have been told that is 3.5 rad per second squared. What else? Now, when t was equal to 1 or when t was equal to 0, that's when we had that's when we had the omega to be equal to 2 rad per second. So what tells me is that this is the initial, because when t is equal to 0, I'm starting at that point. So the initial is 0. I don't know the final. Okay? Then they are saying after 2 seconds, what will be the theta? Which formula do you think we are going to use? We don't have time. Now, using these three formulas here, which formula do you think is going to be the best formula for us to use? Oh, we have the time, right? We have the time. We don't have the final speed. Which formula can we use which requires us to find the displacement, but we don't need to plug in the what? The final speed. Which one? Which one? Which one? Which one? Hello. People from down school. Which formula do you think we are going to use here? Second formula says we have this. So we want to find theta. Now the initial is 0. No. The initial we have, right? The initial is 2. The time is 2. Alpha is 3.5. T is 2. Now we square it. This is 4. This is 4. 2 squared is 4. 4 times half is 2. 2 times 7.5 is 6. 3.5 is 7. So alpha becomes 11 rads. That's the angular displacement. Does that make sense, guys? Let's talk about B. Through how many revolutions? Now we have got theta. Theta is equal to 11 rads. Through how many revolutions has the wheel turned during this time interval? What did I say about revolution? I said the revolution is the same as what? Mzancho Samo, guys. I said the revolution is same as what? Mm-hmm. It's what? 2 pi rad. Okay, so in short, revolution, when the question is asking about revolution, they are still asking you to find the theta. So now, what I want you to understand is that we already have the theta here, and we are going to use this conversion. Sorry? Yes. Mm-hmm. 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 It can be what? Mm-hmm. Mm-hmm. So t is still is so what you are telling me, sir, is this. Let me show you. You are telling me to say um this formula that I have, and then alpha t squared. So at first you want me to plug in t as 0, right? So if I plug in t to be 0, this will be 0, this will be 0. Not so. You have seen, right? Then now the second one, when time is now 2, again I plug in, then that's now the time where I'm going to get 11. So it's 11 minus 0, it still is 11. Yes. You have seen, right? Guys, you can just mute your mics. Okay. So when you're talking about revolution, when question is any question that is asking you to find revolution, they're asking you to find the theta. So we have already found the theta here. Now they want the same time interval. We have already found the theta here to be 11 lads. But I told you to say you can convert one revolution is equal to 2 pi rads. So you are going to say you have got 11, or you don't know the revolution, you put x from grade 2 and you put 11 lads. So you can cross multiply, but you guys know dimension analysis. So I'm going to use dimension instead of this. This is just for someone who is in grade 8. So 11 lads, I'm going to set the unit in such a way that they should cancel each other. So I'll say in 2 pi lads there is one revolution. So lads and lads will go. So it will be 11 divided by 2 pi. Then that is now my revolution. So I don't have my calculator right now, but let me look for it. So if I do 2 divided by 2 pi, what are you going to get? Okay, I have my calculator. So I'll say 11 divided by 2 pi, I'm getting 1.75 revolution. So this is the answer. Through how many revolution has the wheel turned during this time interval? So it's 1.75 revolution. The question continues. So 1.75 rev. What is the angular speed of the wheel at t is equal to 2? What speed are they asking about here? Hmm? So they're asking about the final. They're asking about the final because we know that the initial is 2 when t was equal to 0. Then, now they're asking us to find the final. Okay? So the final will be given by, I can use this formula. So the initial is 2 plus, what's the alpha? 3.5, then the t is 2. So 2 plus, this is 7. So the final becomes 9 rad per second. That's the answer. Have you gotten something? or maybe mushimunzi ni z. Yes, please. Mm-hmm. Mm-hmm. Is that a question, sir? So I'm saying, is that a question? So I repeat on how part B, right? Okay, so you can mute your mic. So the question is, through how many revolution has the wheel turned during this time interval? They want you to find the theta. But now this theta we want to find, they are talking about the same interval which we have at part A. Now part A, we have managed to find that theta is 11 lads as our angular displacement. Now through how many revolution? It's the same theta we are talking about, but they want you to put it in revolution. Okay? So when you're talking about revolution, I want you to understand that one revolution is equal to 2 pi rads. This is the conversion we use to convert. So we have got 11 lads. Okay, so I'll use this. We want to find the revolution. I'll put x, and I want to and I know the lads, which is 11 lads. So we can cross multiply. If I cross multiply, I'll be able to find 2 pi lads times x is equal to one revolution. I'll say one revolution times 11 lads. I'll divide both sides by, I want to find the value of x. I'll divide both sides by 2 rads. Even here, 2 rads, 2 pi rads, sorry. So the rad and rad will go. Here, rad and rad will go. So I've remained with revolution on top and 11 divided by 2 pi. So 11 divided by 2 pi, it is 1.75. But the units now is revolution. Okay. Suppose a particle moves along a straight line. Now, you know this question, sometimes you might be confused. Something is moving in a straight line. That is not circular motion. That's what you need to know. Suppose a particle moves along a straight line with a constant acceleration of the same thing. If the velocity of the particle is 2.00 meters per second at t initial to be equal to 0. When time was equal to 0, the velocity was 2.00 meters. Through what displacement does the particle moves in 2 seconds? They want you to find what? The displacement. Now in this case, it is linear displacement because it is moving in a straight line. So you use the same formula. D is equal to V initial t plus half acceleration t squared. D, the initial speed is what? Is 2. This is the initial speed when t was equal to 0. T is 2. Half acceleration is 3.5. T again 2. D will be equal to 2 times this is 4. Then this is supposed to be squared, so 2 squared is 4 times half 2. 2 times 3.5 is 7. Therefore D is 11 meters. What is the velocity of the particle at t is equal to 2? V final, the reason why I'm not explaining anything because this is under linear motion. The initial is 2, acceleration 3.5, t2. Then this 7, so it gives me 9. Look at this. The answers that we found here, the theta to be 11 lads, that side is now 11 meters. Then the angular speed, we also, this question, what angular speed? This one, we also found the same 9 knots. Also here is 9. Any question? Okay, no question. Suppose a particle moves along a straight line. Isn't it the same question again? Where is question 3? People from across question 3, I can't see question 3 here. Guys, what's the difference between across and misses? Hmm? What's the difference between across and misses? So during a certain period, of time, the angular position of a swinging door is described by theta is equal to 5.00 plus 10.0 times t plus 2.00 t squared, whereas theta is the radius, or is in radians, and t is in seconds. Determine the angular position, angular speed, and the angular acceleration of the door. Part A when t is equal to 0, part B when t is equal to 3. Who doesn't understand this question? Hmm? The reason why I'm asking this question, who doesn't understand this question? But the rest have managed to understand, eh? Okay. Mr. John, you're also behind. You stay on campus? Yeah, sabbaticals, you can't understand this question. Okay, you feel like you are on top of Munungushi. So you need to shift and go to across or down school. Man, down school, if you want to buy food, maybe 24 hours, you have to go up school. Ah, that student center is fake, sir. Oh, so you remember there are some questions we were solving under linear motion where we were given maybe the displacement d. Let me, in most cases they were using s being equal to maybe 2t squared plus, maybe they give you 40, then plus maybe 7. Then they ask you to find maybe the displacement. They will ask you to find the displacement, the velocity, the acceleration, and they will give you time. They will say t should be equal to maybe 0, and t is equal to maybe 2, and also t maybe is equal to 4. Do you remember this? You don't remember? No, you're not supposed to be in the group. Okay, it is there in the throw sheet. So I assume that you guys you know it. So now this is what we call the function. Okay, so this is the position as the function. So we are dealing with t. So this is basically I can write this. This is the quadratic function. You get my point, right? So this is the quadratic equation function. So it's like this: t squared, then plus 10.0 t, then plus 5.00. Now I want you to listen and listen very careful. If you want to guys, send him my 6 point him first. You guys are the same people who got my 6 point, right? Ah, okay. You guys, I know. You guys are the same people who got my 6.7. You're even shining at 8 out of 8. So now, when I want to differentiate, I've got a function. When you've got a function, maybe f of x being equal to x to the power 3, then I want you to differentiate this. What is the y over the x? I'm a 6 point. So, what of x raised to the power negative 2? I want to find the y over the x. What would be the answer? Okay, I want you now, let's go back to that. Now, as long as you know how to differentiate, then you'll be able to solve that. Anyone who doesn't know how to differentiate, because this is going to help you for circular motion, even next year, I'm confused. Even next year is going to help you a lot in terms of the first topic that you are going to do in physics. Okay, which is waves and vibration. So, whenever you have been given this, when you are differentiating, you drop the power reduces by 1. So we have dropped 3, then the power reduces by 1. So it's 3 minus 1, which is 2. Here we have dropped negative 2, which is negative 2 here. The power reduces by 1. So negative 2 minus 1 is negative 3. As long as you have been given such equation, for you to find the velocity, you need to differentiate this thing with respect to x. So the derivative of 2, in this case, we are going to drop the 2. That becomes 2 times 2, it becomes 4.00 times t. Then plus, again I drop 1 here, which is going to be just 10. When I use this formula, then that is going to be the velocity. When I want to find the acceleration, now we are talking about angular velocity, so it's going to be this. When I want to find this with respect to x or with respect to t, again I differentiate the function of the velocity. So this becomes just 4.00. So these are the formulas I'm going to be using. The first one, when t is equal to 0, I'll use the same one. And when t is equal to 3, I'll use the same ones. Who doesn't understand how we have come up with these equations? Hmm? Okay, as I'm waiting for people to respond, let me eat some tomato cornflakes because I'm hungry. Okay, we are okay. Mr. John, you are complaining that you can't understand. Serious? Agape, you can see the screen. We are just differentiating, guys. So you differentiate the first function. Now the first, when you differentiate the function of the displacement, and here for those who are going to be with me during the holiday, since we are going to do semester 2 work during the holiday, I think we are going to cover half of it. I want you to I'm going to remind you this, because you are going to be having tests where you are going to be required to do this for semester 2 work, the first topic. So when you have been given this, the one for the position, we're talking about the displacement, which is theta in this case, because they're talking about angular. When I differentiate the one for theta, the equation I'm going to get is for the velocity. When I differentiate the one for the velocity, the equation I'm going to get is the one for acceleration. Deal done. Now let's go back and plug in the values. Theta as time, when time is 0, what will be the value? 2 0 squared plus 10 0, then plus 5. So this will be 0, this will be 0. So theta when time is 0 is going to be 5. Now because we're talking about angular position, that becomes rad. W when t is equal to 0 is 4 times 0 plus 10. Okay? So what are we going to have? This becomes, this 0, then is 10 rad per second. Now let's go back to acceleration. So alpha as time t, now t is now 0. So there is nowhere I'm going to put t here. So that becomes just 4 rad per second squared. Now the same formulas I need now to replace that part B. This is A. We have solved A. Part B, when t is equal to 3. So I'll start again. Alpha when t is equal to 3, 3 raised to the power 2 plus 10 plus 5. Theta as a function of 3, that is 9 times 2 is 18 plus 10 plus 5. 5 plus this is 15, 15 plus 15, that is 30. 30 plus 3, 30 plus 3. What am I doing? 9 times 2, 18. So here we have forgotten t, right? Yes. So this becomes 18. This becomes 10 plus that is 10 times 3, that is 30, then 5. So we have got that is 23. 23 plus 18 plus 5 is 23. 23 plus 30, that is 53. So Q, our theta, that becomes 53 rads. Then now we go back and also solve the one for W. As time is 3, we are going to have 4, put 3 here, plus 10. So that is 12. 12 plus 10 is 22. That is rad per second. Alpha as a function of t, which is going to be 3, is just 4.0 rad per second squared. I'm done with this question. You follow me, huh? So Apa, this is going to help you again also for semester 2. The first topic. Well, that one I'm going to teach you during the holiday. Yeah, so that's how it is. If you want to find the revolution for part what? Part A. So this is the revolution. Now you convert this 5 rad into revolution. So it's going to be, in one revolution you have got 2 pi rad. So we want to convert 5. Let me put it here. So it's going to be, in 2 pi rad we put 1 revolution on top, so these will cancel. So it will be 5, you divide it by 2 pi. So you see 0.7957. If you round it off, this gives you 0.8 revolution. Circular motion is not, it's not something that is complicated, especially if you have got ideas of linear motion. Let's talk about this question now. A dentist drill starts from rest. When something starts from rest, what comes in your mind when it comes when you're talking about 0? So a dentist drill starts from rest, the initial speed is 0. After 3.20 seconds, meaning that is time, of a constant angular acceleration, it turns at a rate of 2.51 times 10 to the power 4 revolution per minute. What is this now? Hmm? That's angular speed. So yes, it's angular speed. Is it the final or the initial? Hmm? It's the final. So the final is 2.51 times 10 raised to the power 4 revolution per minute. I want to make things clear here. This time is in second and this guy is in now revolution per minute. I can't work out with the revolution per minute because time is in second. Like I said, I told you here to say these are the SI units we are going to be working with. So I need to convert now revolution per minute to revolution per what? Not revolution. I need to convert from revolution per minute to rad per second. So I'll write this here. I'll use dimension. Revolution. So you put the minute down here. You say in 1 minute. This in 1 minute, not in one revolution. In 1 minute, like this. This means that 2.51 times 10 to the power 4 revolution in 1 minute, that is per minute, times. Look here. So what you do is this. You are going to set the units in such a way that they should cancel each other. In one revolution now will be down because I want to cancel revolution. In one revolution we have got 2 pi rad. Now revolution and revolution will go. Again I need to cancel minutes. In 1 minute, how many seconds do we have? We have got 60 seconds. So minutes and minutes will cancel. You get your calculator. You say 2.51 times 10 to the power 4 times 2 pi. The answer you get, I'm getting 157,707.9512. You divide that by 60. So now I'm getting my final speed as in rad per second to be equal to 2,628.465. That is now rad per second. For you to get the accurate answer, you need to have at least 3 decimal places here that we are going to be working with. So this I can write it to say it's the same as 66. Then I remove 8. Now, based on this information, based on this information, let's go back and now continue with our question. Part A. Find the drill's angular acceleration. Which formula can we use for us to find the angular acceleration provided we don't have the theta? Using these formulas I gave you. So this requires us to have theta, this requires us to have theta, then it's the first one. So I'll use the first one, which is final initial plus this, shift this to go to the other side, is equal to alpha times t divided by t. Therefore alpha is equal to minus initial divided by t. Let's plug in the values. Final is now 2,628.466. I divide this by the time, which is 3.2. So therefore alpha will be equal to, that is 821. So 821.4 rad per second squared. The reason why I'm going to leave it for 0.4, but in most cases we look at this. This is in 2 decimal places, this is in 2 decimal places. So even the final answer should be in 2 decimal places, but the answer that I was getting here goes like this. So the answer that I'm getting is again here there's 3, then there's 9, then there's 5. So I want to leave it in 2 decimal places. That's why it's going to be 5. If I round it off, this one becomes now 40, then 0. So that becomes now rad per second squared. This is the angular acceleration. Any question? Okay. The next question is saying determine the angle in radian through which the drill rotates during this period. What did I say about the angle? When they're asking us to find the angle, they want us to find what? Angular displacement. So angle is the angular displacement, same as revolution. So we have, which formula can we use now, provided we have everything? So I can use any. I can choose either the second one or the third one. So the second one, theta is equal to this alpha t squared. Then alpha will be equal to, the initial is 0, meaning that this has gone, half, the angular is 821.40, then t is 3.2, I square it. So theta will be equal to that answer we have found, then times 0.5 times 3.2, I square it. So the answer that I'm getting is 420.55. Okay, now they are saying in rad. This is already in rad. If you use this other formula, you still end up having the same answer. At your own free time, go ahead and make theta as a subject of the formula. Go and use that formula. If at all you are going to get the same answer. For today's class, it's your network, sir. No, it's your network. It's my network. You guys, yes, because me, the network I'm using, I'm up, I'm here across, but the network that I'm using is very strong. So this is what I had for you this morning. We're going to have another class. But for those today, Kairi, I wanted us to look at circular motion. So for those who are not registered, I wanted you to at least to have ideas of circular motion. I don't like leaving people behind. But in the afternoon, you're not going to attend if at all you have not registered with us. So you know what to do. So you can register and access these online classes which are going to help you a lot. So you can leave the meeting unless you have got questions. You can inbox me. But if you are not in the group, you're not in the group, eh? So for those who are not in the group, you are supposed to text this number. You are going to be added in the group. Where is the number? I want to get the number so that you text this number, then you'll be added in the group. You just text to say add me in the group. So you need to specify which group. They'll add you in the group for Unilaska. So when you text this number, specify. You say add me in the group for, I don't know what group you. So plus 26097 958 0034. So you can text this number on WhatsApp. At the same time, if you want to register, you can also text this number. You'll be helped. Okay, you can leave the meeting, guys.